All right, congruence. Builders of houses will often have one floor plan and they will use that floor plan over and over again. In other words, you can have two congruent houses or two houses that are identical to each other. And that helps to save on cost because it's predictable exactly how much material, what it will be, and all the builders who construct these houses get used to making that exact same house. So it's a lot easier for them to do. All right, so congruent figures, just like these two houses, they have the same size, the same shape, and their corresponding parts are going to be equal or congruent. And congruent is just an equal symbol with a little squiggly over top. And now an example with that is if we had triangle ABC and we knew that it was congruent to, and I just have the congruent symbol, the equal with the squiggly, to triangle XYZ, then I actually know a whole bunch about these two triangles. And if I just start with the angles, angle A, look, that's my first letter, this is my first letter, so angle A is congruent to angle X. Let's look at another one. Angle B, that's my second letter, is congruent to angle Y. So even without seeing these triangles, I know this is true about them. So the order in which they're written is important. So C is my third letter there is Z, so angle C is congruent to angle Z. So that's what I know about the angles. Now the sides are going to be very similar to that, except how many points do we need to label a side? 2. So look at my first two, like AB, and my first two here would be XY. So I could say AB, or line segment AB, is congruent to line segment XY. And now I could say my last two, my BC is congruent to my last two here, which is my YZ. And then the very last relationship there is going to be the first and the third. So AC is congruent to XZ. All right, so all the angles and all the sides, or corresponding angles and corresponding sides, are equal or congruent. All right, let's do another example. And this time I'm going to give you the picture as well. So start by just drawing a vertical line segment, and then draw a line that's perpendicular to that, and then straight down. And then we're going to connect those. And don't worry about your picture being perfect. Mine, two triangles are not identical. They should be close though. I'm going to label this one P, this one's Q, this one's R, S, and T. And I'm going to give you triangle PQR is congruent to triangle STR. And now I want you to list all pairs of congruent, and I forgot my squiggly, congruent sides and angles. And let's add one more thing to our picture. I'm going to make this a right angle. I told you those were perpendicular earlier. And one more question, I want you to also find ST and QR. So find the length of those two segments. All right, let's fill in a couple things on our picture. I'm going to call PQ is 6 meters. I'm going to say PR is 8 meters. RT is 10 meters. And that's all I'm going to give you. So based on that information, we need to list all pairs of congruent sides and angles. So I'm going to do that first. So look at my angles. Just looking here, I'm seeing angle P and angle S have to be the same. So angle P is congruent to angle S. And you can see because they both have right angles too. That's another way to prove it. Another relationship, angle Q, my second letter, is congruent to angle T. And you can look at those. Those are both acute angles there. So Q and T are the same. And then I could also say that angle R, that's my third letter, is congruent to angle R. Now wait a second. I can't just call it angle R because R has 1, 2, 3, 4 angles that could be associated with it. So I need to be more specific. So I'm going to use 3 letters to name that. So how about QRP and SRT? Angle QRP is congruent to angle SRT. So again, if there's any confusion, in other words, if angles share a vertex, you have to make sure you're using 3 letters. All right, now let's talk about the sides. So PQ, those are my first 2, and S2 are my first 2. So I could say PQ is congruent to ST, and I can show that using a hash mark on my picture. So PQ and ST are the same. And I just realized I didn't put the arcs on my last 2 angles. QRP and SRT are the same, so I could put 2 hash marks, or 2 arcs right there. All right, what are my other congruent sides? We have QR, my second and third, and TR. So QR is congruent to TR, and I'm going to put 2 hash marks for QR and 2 hash marks for TR. And I have one more. I could use my first and my third, my first and my third. So PR or RP, I could say. So RP and RS. I could also say PR and SR. And I can show 3 hash marks there. So 1, 2, 3, and 1, 2, 3. All right, now we're finding ST. We've done the first part of our question. ST is the same thing as PQ. So do I have PQ? Sure, PQ is 6. So I'm going to say ST equals 6 because it's congruent to PQ. And then my other one is QR. QR is right here. So QR is congruent to TR. So do I know TR? Yeah. TR is 10. So I can say that QR is going to be 10. All right, and another way to draw the, let's say you didn't know this right here, but you knew all this. So if you just had the picture, how could you write the congruent statement? Well, if you started from the right angle and went to the smaller angle to the smallest angle, like that, then it would be PQR. What if you did the same thing here? You went from the right angle vertex to the next smallest angle to the smallest angle. You could say it STR. So that's another way that you could write the congruent statement from just a picture. So you have to go in order. So like I said, PQR, and STR. All right, next thing on tap, let's prove how triangles can be congruent to each other. All right, you know how a puzzle works. If you find a few pieces that fit together, sometimes that's all you need to really get the puzzle moving quickly. Well, that's the same for triangles. If three certain parts of two triangles are congruent, then both triangles are proven congruent. And there are 4 different ways that we can prove that. And your 4 methods are side, 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 angle, side, angle, side, angle, and angle, angle, angle. Correction, that was angle, angle, side, my bad. Alright, for side, 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 just draw one triangle that looks like this, just like an equilateral triangle, and 1 hash mark, 2 hash marks, 3 hash marks. And then just draw one that's opposite of that, so one that's pointing downward. And it's going to go 1, 2, 3. So in other words, this is side, side, side. So if you've proven all 3 sides from both triangles are the same, then the triangles are congruent. Alright, side angle side is going to look something like this. For that one, let's just draw kind of like an hourglass, but with triangles. So there's the letter Z, and I'm just going to connect the letter Z diagonally. And I'm going to put some hash marks. I'm going to put 2 hash marks on the top left, 2 on the bottom right. I'm going to put 1 hash mark on the top right and 1 on the bottom left. And then I'm going to use an arc to show that these 2 vertical angles are the same. We know vertical angles are congruent. So here we have side angle side, so side angle side is congruent to side angle side. So that's how we get the names from here. And I'm just going to write down a note. The angle is directly in the middle of the congruent sides. And it's important you jot that down because some people get that mixed up. So the angle is between the 2 congruent sides. All right, what do you think is the case here? Angle, side, angle. The side has to be what? Between the 2 congruent angles. So on this one I have draw a triangle that looks like that, and then I'm just going to draw the mirrored image of it. So a long skinny one, a shorter one, and then connect. And then I'm going to do angle, side, and then angle. I'm using 2 hash marks there. And then you may have guessed that this one's going to be 1 arc, that would be 2 arcs, and that's my hash mark. So here we have angle, side, angle, angle, side, angle, and notice the side is between the 2 congruent angles. It's got to be right in the middle of them. Alright, one more to go. Angle, angle, side. I'm just going to draw 2 equilateral looking triangles. And I'm going to put 2 arcs on the bottom left, 1 arc on the top, a hash mark on the top right. Then here I'm just going to do a hash mark on the top left, an arc on the top, and then 2 arcs on the bottom right. And now look at your diagram. We have angle, angle, side. So notice the side has to be not in between the 2 angles, but outside of the 2 angles. You could also say side, angle, angle. So side, angle, angle, or angle, angle, side. Angle, angle, side, side, angle, angle. So that's how that's read. So way to remember all these letters, because that can be overwhelming. Congruent triangles, they don't drink, and they don't curse. They're nice triangles. So congruent triangles don't curse or drink. So it can't be angle, side, side. That can't work. And it can't be angle, 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 like Alcoholics Anonymous. So it can't be AAA or ASS. And that goes backwards too. So it can't be side, side, angle. And that one backwards is the same thing. So those are not going to be examples of congruent triangles. In other words, it's not enough information if that's all we have. Well, what would those look like if we drew an angle side, side? Well, let's show one. So if we draw, I'm just going to draw an equilateral triangle or one that looks similar to that, and then one that's upside down. And then hash mark, arc, arc, hash mark, hash mark. And I just realized this one I want to have two hash marks, the top and the bottom there. All right. So reading that, that would be side, side, angle, or angle, side, side. So that's what it would look like if we don't have enough information. Same thing here, angle, side, side, or side, side, angle. So those are not congruent. And they might be, it's just we don't have enough information. And then the other one I could do an example of, but I think you guys know, you don't need to write this down unless you want to. For the AAA, that would be like if you have a small triangle and a big triangle. Just because you prove that they have the same angles, I mean, one of them could be a mini-me, and the other one could be the Dr. Evil. So just because they look the same doesn't mean they're the exact same size, right? Mini-me's very small compared to Dr. Evil. I'm sure they're equally as evil, and not quasi-evil. And I bet you didn't know Dr. Evil and Mini-Me had anything to do about math, but there you have it. Thank you, Dr. Evil. Thank you, Mini-Me.